Hello everyone, I am Radha Kumari Pani, Assistant Professor at VIT. So today let's start with the topic that is phase transformation. Okay, now what is phase and what is transformation? Phase is on the state of medium of any matter. Okay, generally there are three phases like solid, liquid and gaseous are there. Transformation means by upon heat treatment or by doing something we can change its phases like from solid to liquid, or we can change liquid to gas of any phases. Okay, between these three phases we can change of any state of medium to any state of medium, means any phases to any phases by doing something or by applying some heat. So this is called the phase transformation, and this is very important topic in metallurgical engineering. By doing some phase transformation we can change the properties of metallic material, and by changing its property we can see in it different application in different field. Okay, so now first, what are the course objective or what is the aim of this topic phase transformation? Means we have to understand what is the role of phase transformation in the application or development of mechanical property. Okay, properties that is called microstructure. We can change atomic structure to microstructure upon heat treatment. So what is the application by doing phase transformation we have to learn in this topic. So now this course will highlight the important or significant application, okay, where phase transformation are important. So what are the course overview, and this is the content. I will show you next slide. So what is the outcome? What by learning this topic phase transformation, what will the outcome? And this will provide the huge analytical and problem solving skills in metallurgical science, and we have to understand what are the principles underlying this topic, like from solid to liquid or liquid to any states. And now we will see the what is the importance of phase transformation. Okay, what are the importance of phase transformation for controlling the microstructure property and the various application in metallurgical science field. So now what are the main content in phase transformation? First in introduction, then the thermodynamics and kinetics will cover one by one. Okay, now diffusion, interfaces in metal, different like topic is there. And first okay, now the references we can you can refer the various like reference from phase transformation in metals and alloys by D.A. Porter and M.I. Sharif, and diffusion in solids we can refer the Professor Alak Paul, and phase transformation Professor Anand Subramaniam, IIT Kanpur. Now universe, first is divided in space and energy. Now the space we can hyperbolic, Euclidean, spherical, we can say. The energy, like different entropic force is there in the term in energy. In the terms of force we can divide it into four categories like strong force or weak force, electromagnetic force, or any gravitational force. Okay, so now energy in particles, there are like particles generally, that is atom and non-atoms are there. Okay, and atomic particles, there are according to like band theory. Okay, according to band theory the atoms are divided into four categories. First one is metal, second one is semi metal, third one semiconductor or insulator. First we have to understand what is band theory. Band theory is nothing but this is the theory which tells about the how the electrons are goes from HOMO to LUMO. First, what is HOMO? What is LUMO? First, HOMO means it is called highest occupied molecular orbital. In solid, in the solid materials, the metals are staying in randomly arrangement or orderly arrangement, so that their molecular orbitals are overlapping. Okay, the molecular orbitals are overlapping, so that the one electron can transform from one phases to another phases, or we can say one orbitals to another orbitals. First, we have to understand what is HOMO. So, according to band theory, the electrons are staying in HOMO, that is highest occupied molecular orbitals. Okay. the electron are staying in HOMO can goes up to LUMO, that is the lowest unoccupied molecular orbitals, means this molecular orbital is vacant, so that the electron can transfer to these orbitals. So according to band theory, the HOMO can be called as valence bond and the LUMO can be called as conduction band. Okay, so the electron are goes from valence bond to conduction band. The transition, it is going out from valence bond to conduction band. So that in the band theory, in metals, this energy gap, okay, these LUMO has some energy and HOMO has some energy. So the energy difference, it's called band energy. Okay, so in metal the bond energy is very less, so that by doing some treatment, okay, heat treatment, we can transfer the electron from HOMO to LUMO. It is very easy. So but in contrast to metal, the insulator or the non-metal, the band energy is very high, so that we cannot easily transfer the electron from valence band to conduction band. Okay, so this is called the band theory or band structure. Now the atoms according to state or viscosity, it is I have already told in the first slide that gas, solid and liquid, or liquid crystals, we can say plasma, another phase one is there. And now the solid, the structure can be classified into crystals, amorphous, quasi-crystal. Now the crystal, and what is amorphous? See, in the crystallic material, the metals are orderly arrangement. Okay, orderly arranged materials are there in crystal structure, but you cannot see the order arrangement of material in amorphous materials. So in amorphous metallic material, there is not a defined structure or not defined arrangement of metals. Example we can say in amorphous, like glass or rubber, plastics. These are the example of amorphous crystals. Okay. So now according to size, there is a different crystal, like nanocrystal, means the size it is in nanometers. Okay, and another one is nano quasi crystals. This is a different part. Okay, we don't need to cover this. We have to cover only the nanocrystals or nanomaterials, means the size is in nanometer, 10 to the power minus 9 meter. Okay. Next, classification of materials. First, the materials is classified into monolithic and a hybrid. What is monolithic? Again, monolithic is divided into three categories, like metals and composites, like ceramic or glasses. Now polymers. Now the hybrids. Hybrids can be classified into four categories, like composite materials, sandwich, lattice, different structure, different materials arrangement, so that the difference is the name. First, what is composite? Composite materials means it is the combination. Okay, it is the combination of different material. One is matrix and another one is reinforcement. Matrix, we can say this is nothing but any metal we can take matrix. Matrix means that is uniformly distributed materials. Okay, we can say any example like aluminium, it can be nickel, it can be lead, anything that is uniformly distributed, so that the reinforcement is embedded in any part of the surface. So the composite materials, again it is like four types: polymer matrix composite materials, another one is metal matrix composite material, or carbon. Okay, carbon matrix composite material. One is polymer matrix composite material and metallic matrix composite materials, and another one is carbon matrix composite materials. So now the second one is sandwich. From the name it is clear. Okay, sandwich means the like one materials, okay, should be in the surface, like either one side or dual side. It can be either this side one like materials on the surface, or in the lower side we can set the sandwich, and the core material is in between. This is the another type of hybrid materials. Now the lattice means this is typically the combination of one metal and another is space, like air we can say. Example is aerosols. Okay, it is the type of gel in which the liquid like metals are replaced by a gaseous. Okay, it is like the ultratonic one gel is there, aerosols. Okay, this is classified in terms of lattice. Now the segment structure means it can be divided in 1-dimensional, 2-dimensional, 3-dimensional according to their dimensional structures. So these are the materials, one is monolithic and one is hybrid, and according to different their arrangement, metallics arrangement, they are classified into different categories. So now what is the length scale in metrology? This is the very important. We have to know also what is the length scale in according to their size. Okay, according to their length scale, there is different metallic like nanostructure, microstructure as there. First, atom through structure. Structure could be two types, like crystal structure, and another one is electromagnetic structure. Now the microstructure can be transformed from the structure by doing some thermomechanical treatment. Okay, by doing some thermomechanical treatment, we can transfer the structure from microstructure to microstructure. Now the microstructure, it is combination of phases, defects, and the residual force. What is defects? Defect can be any type, sorry, dislocation, diffusion, voids with small cracks. We can say this is the defect. Now from the microstructure we can change into component, and the component, it is a various huge application in material science is there. Like here it is written that casting, metal forming, welding, power processing, different types application are there. Okay, we can see by changing small changing, we can transfer the structure of metallic material from like structure to microstructure to component, and there are different huge application in material science is there. So now the length scale it is. Okay, first the unit cell, it is the fundamental cell in the any metallic material. We can found the unit cell, and unit cell, the size of the unit cell in 10 to the power minus 10 meter, that is angstrom. Okay, from now angstrom to small dislocation we can change it to nanometers, the size in -9. This is minus. Okay, 10 to the power -9 to 10 to the power -7 meter, the size is there in for nano crystalline material. Then microns, microstructure, this is the type of structure we can examine in micros level. Okay, we can examine under the microscope. The size is general 10 to the power -6 to 10 to the power -5 meter. Then the component size is in centimeters. Okay, 10 to the power 1 to 2, like yes, 1 meter, 10 to the power in centimeter. Okay, 10 centimeter or 10 to the power like something 2 centimeter, it is there. So different structure of metallic material, there are different size. Okay, now the transformation in material like phases, we have in the last slide we have seen that the microstructure, it is the combination of phases, defect, and residual stress. So now the phases can transform into two categories, like geometrical structure and physical property. Okay, the defect structure can change, so that we can say it defect structure transformation, and the residual stress also can be altered, so that we can say stress state transformation. Phase to microstructure, or phase transformation to microstructure transformation. What are the transformation we need? That is called phase transformation to microstructure transformation. So these are the introduction part of your phase transformation. Okay, in the next slide we can see the classification of transformation, the order of transformation, like it is first order or second order. Okay, generally the phase transformation according to thermodynamic property, it is the thermodynamic characteristics. According to thermodynamic characteristics, phase transformation can be it is first order or second order, we can say. Here it is written that the derivative of free energy with respect to temperature, the derivative of free energy with respect to temperature and pressure is discontinuous. It is defined as the nth order transformation. Let some example. This is the G, free energy. Okay, this is called free energy in thermodynamic word, and this is the T, is temperature. So if the first derivative of free energy with respect to temperature, we can say like this, del G by del T. Okay, it is known as enthalpy, H. Del G by del T is H. It is discontinuous. We can see derivative of free energy with respect to T, H, that is del G by del T with respect to T, it is discontinuous. This is not in continuous form. Okay, if it is discontinuous, then the order is first order, because here the order is 1. So this is called first order. Now the second derivative of del G, if we are taking del square G by del T square, it is also discontinuous. We can see here Cp, del square G by del T square is known as Cp. Okay, so it is also discontinuous and it is the second order phase transformation. So according to thermodynamic characteristics, we can say the phase transformation if the nth order of gives free energy with respect to temperature or pressure, if it is discontinuous, and that the nth order is called first order or second order transformation. So these are the classification: transformation, heterogeneous and homogeneous transformation. Heterogeneous means some part of the surface is going to transfer, is going to change. But in case of homogeneous transformation, the whole surface, okay, the whole surface of the materials is going to change. This is called homogeneous transformation. And the heterogeneous transformation, generally it is like nucleation and growth. In nucleation growth means it is growth can be controlled by the heat transformation, heat, or also the mass transformation. This is called the solidification of pure metals, in solidification of alloy. In future classes we will cover all these topic. Okay, so we can overview this classification of transformation, okay, by heterogeneous and homogeneous. What are the topic we have to cover? And this is the in word form. Okay, phase transformation can be classified in homogeneous and heterogeneous. And the transformation are thermally activated, means by doing some heat treatment. Thermally means heat, nothing but heat treatment. While these are the transformation can also be diffusion control or interface control. And now the some transformation, they are composite like changes. In some there are no composition, no changes. Okay, composition means there different materials are there. In some transformation the composition is same. Okay, composition is same, but the property is going to change. But in some transformation composition is not going to change. Okay, for that transformation which can be diffusional, either the long range diffusion or short range diffusion. We'll cover all this topic in next classes. Okay, next we'll see the thermodynamic and kinetics. In next classes I will teach this, what is thermodynamics and kinetics. Okay, thank you.